Hello and good morning, good afternoon, good evening to wherever you are. Thank you all for joining us today. My name is Jeff Blankenburg, and this is an episode of Alexa and Friends. Today, I have the good pleasure of being joined by Kayoko Yanagisawa, who is on our Alexa text-to-speech team. Thank you for being here, Kayoko.
Nice to be here. Thanks for having me.
Certainly. So one of the fun things that we like to do when we start these interviews is to dive right into some kind of silly questions that let people get a feel for who you are and what your personality is like a little bit. And so the first question I'd like to ask, I don't know a lot about you. You and I haven't had a lot of chance to talk yet. Do you have any kind of musical background? I noticed you have some musicians there behind you on your wall. Do you play any instruments?
Yes, I played viola.
Viola, very nice.
Yeah. And I actually made my own viola.
Oh my goodness, you made your own. Wow, that's pretty cool. I played the clarinet when I was younger, but I did not make my own clarinet. I had the clarinet that my grandfather played way back in the 40s, and then he gave it to my father, and then I took it, and I still have it. It's a really nice old wooden clarinet, but I haven't played it in many years. I think I still could, though.
Well, no, I haven't played it since the lockdown.
Yeah. The reason I'm asking about your musical background is because one of the questions that I like to ask people is that I want you to imagine for a moment, maybe you're in a small musical group or a band, and you've recorded your first album of unique music. What would the name of that first album, your debut album, what would you call that album?
So I was leading that band. I might call it Kattan, because so my first language is Japanese, and in Japanese we tend to avoid pronouns, and but young children, when referring to themselves, they sometimes use their names. So you use your name to and refer to yourself in the third person. So I might say Kayoko wants to eat, Kayoko wants to drink. But because I couldn't say my name when I was younger, I used to call myself Kattan, and so that's how I started calling myself. And that's
is that a nonsense word in Japanese, or is that does that mean something?
No, it doesn't mean anything.
Okay,
it's just how I called myself, and that's still how my parents call me.
That's very fun. My parents always remind me. I used to refer to the food spaghetti as pischetti, and so even now when we get together with my family, if we have spaghetti, my mom will remind us of how I used to say that. That's a great story. Okay, so second question. This one is very insightful sometimes. I want you to imagine of all of the superpowers you've ever heard of superheroes having, maybe in the comic books, things like that. If you got to pick one for yourself, just one superpower, you don't get to be Wonder Woman or Superman where you have lots of powers combined together. Just one, what would you pick?
I'd probably pick being able to manipulate time. So if I'm doing something that I really like doing, I want to spend a lot of time on it. Sometimes I don't want to go to bed because I'm enjoying it so much. Right. But if I'm at a dentist, I'd want to get that over and done with as soon as possible.
That's fair.
And if you ask me an awkward question, I would pause the time for everyone else to give me time to think and come up with a clever answer.
I like that. So it's almost like a pause and a fast forward button.
Yeah.
Very cool. Yeah, I would definitely be down for that. And I always like to ask this question because most superpowers can be used for good or for evil. So how would you use that superpower for good? Like, what's something that you could use that power for to like create something, like do something good for other people or something like that?
I guess it could be used for good in many ways. Like if I saw somebody like trying to attack someone, I could stop the time and remove the about to be victim from.
I like that. That's a really good use of that power. That's excellent. It's always interesting. It's very easy to think of evil ways to use superpowers, right? You could just pause the world, walk into a bank, steal all the money. Like that's an easy kind of outcome, right? And a lot of people that want invisibility have the same thing, right? I can just sneak and go around wherever I want to go. There's a lot of benefits to superpowers too that are positive. All right, so we're gonna move on to my last one. This one starts with a little story. And so I want you to imagine you're in a big city. Where in Japan did you grow up?
Well, I actually grew up in the UK.
Oh, I apologize. So you learned Japanese, but in the UK?
Yes, well, at home I always spoke Japanese.
Got it.
Yeah, I grew up in Surrey in the UK.
I apologize for asking that. Did you ever actually live in Japan?
Yes, yeah, I was born in Japan.
Okay.
And then I moved here when I was 10.
So I was going to use the city. I've been to Tokyo a couple of years ago, and I was going to use Tokyo as an example. It's a huge city. London is obviously a huge city as well. But I want you to imagine that you're walking down a street, and the place that you need to go in this huge city is 1 block over. So you need to either walk down the big city block and around, or you see there's an alley, and you could just cut down that alley. Now, it's a beautiful day. It's sunny. It's a brightly lit alley. There's nothing dangerous about this alley. So you decide you're going to walk down this alley to the next street over. And about halfway through this alley, you notice at the end that you're heading towards that a giant horse-sized duck appears in front of you.
Okay.
It looks a little aggressive. It doesn't look like it wants to be your friend. And so you, as anyone would, you turn around and you start to go back the way you came, only to realize that it has now been closed by 100 duck-sized horses. Very small horses, right? So my question for you is, you are now trapped in this alley. And you need to go one direction or the other. Which end would you choose to go towards, knowing that you're probably going to find yourself in a small fight?
So anyone who knows me will tell you how frightened I am of any animal. So even the cutest little puppy I would run away from. So this would be like a nightmare situation for me. I would probably go for the, what was it, horse-sized duck?
Yeah, 1 big duck or 100 tiny horses?
1 big duck. I'd probably go for the 1 big duck, and because I can probably throw a stone and distract that duck.
That's the first time I've heard of anyone trying to distract the duck. That's not a bad option. I like that.
I think it would be easier to do that than to try to distract 100 horses or ducks, whatever.
Well, I always like to get people to think about the fact that if you were just at the park and all of a sudden you were surrounded by 100 ducks, just normal ducks, that would be terrifying.
It is, yeah.
That is a lot of ducks, 100 ducks. All right. Well, thank you for entertaining me with those silly little questions. I would love to get to know more about you, and so we're going to jump into that next. And from my initial question is, I always like to ask people to kind of give me their quick 4 to 5 minute rundown on what their career has looked like. I think you, more than some of the people that we've had on here, have probably had a pathway that led to where you are today based on your education and things like that. But I'd love for you to kind of share maybe where you went to college, what your focus was, and then any of the major milestones that kind of happened during your career to get you to where you are today.
So to start with, where I went to college, I went to university in Japan. So I mentioned earlier that I was born in Japan, but grew up in the UK. So I moved to the UK when I was 1, and when I was 7, I moved back to Japan. And when I came back to the UK at the age of 12, I'd forgotten all the English grammar and vocabulary, but the one thing I retained was pronunciation, and that was the first thing that got me interested in phonetics, which is the sounds of languages.
Yeah.
And I thought there was something special about the human ability to speak, and that was the first thing that got me interested in speech. And at school, I learned French and German, and learning a Romance language and a Germanic language got me interested in the differences and similarities between those languages. And so when I went to university, I took up Spanish, Russian, Latin, and ancient Greek. And I majored in French, but this was in Japan. So yeah, I went back to Japan for university. And when you major in French or in any foreign language at a university in Japan, you start from scratch because English is their second language. And so people usually have no prior experience of other foreign languages. And since I already had 6 years of French under my belt, that gave me time to explore other subjects like linguistics, phonetics, and language science instead of attending French lectures. And then as I was graduating, I was torn between going on to a postgraduate degree and going out to work outside of academia. And I thought if I went straight into academia, it might be difficult for me to get out later. But if I go and work outside of academia, then if I had the passion, I could always come back to do research. So that's what I ended up doing. And I landed a job as a journalist at the Nikkei, which is a financial newspaper company in Japan. And this is where you might think, what?
Right.
But for me, this was an important step in my career, which steered me towards where I am now. It wasn't actually journalism per se that I was interested in. And I'd actually applied to be a proofreader at the company. And this is a person who reads through stories that other people wrote and corrects typos and grammatical errors and does fact checks. And I was applying for this position all along. But after the final interview, I was told that I'd got the job, but not as a proofreader, but as a journalist in the international news department.
Wow.
And so I was basically hired for my linguistic skills. And so I then spent some time interviewing heads of states and other political figures from abroad as they visited Japan. And I conducted interviews in English and French. And just so that my colleagues don't get the wrong idea about my French proficiency, I want to add that my French has been going downhill since I was 18, which was a long time ago.
Yeah.
And anyway, after a while, I started to miss life back in the UK. And I also felt a bit frustrated at the lack of dive deep in my day-to-day life. And so I moved back to the UK and did a master's and PhD at UCL, University College London. And my master's was in phonetics, and it was an arts subject, but it gave me an introduction to speech acoustics. And then for my PhD, I wanted to work on something more speech technology oriented, because during my years as a journalist, I'd had the opportunity to interview someone who had started a company developing speech recognition software. And so speech technology was a field that I was intrigued about. And I knew that I wanted to work on something that would have a practical use. So for my PhD, I worked on the topic of spoken language conversion with accent morphing, which essentially tried to generate the speech of a person in a foreign language whilst keeping their speaker identity.
Wow.
And there I used text-to-speech, but was still not involved in developing it. And as I was finishing my PhD, I found a position at the in the speech team at Toshiba's R&D lab here in Cambridge, UK. And there I had the opportunity to work on developing TTS for the first time. And I worked on developing the front end of TTS for various languages. The front end is the component that converts from text into a sequence of phonemes or sounds. And while I was there, I had the chance to work on speaker adaptation for TTS. And this was a steep learning curve for someone from a non-engineering background like me. But the project gave me a good overview of the entire TTS pipeline, including the back end, which is the bit that converts from the sounds into an acoustic waveform.
Right.
And it was also there that I had the opportunity to learn a bit about automatic speech recognition, and also collaborated members of the computer vision team to develop a talking head synthesis system, which is a computer animated avatar. Wow. Where expressive speech synthesis is synced with facial movements.
Wow.
And ASR and computer vision are fields from which the TTS have adopted various techniques in recent years. So that was a valuable experience for me. And then in 2016, I joined Amazon's TTS team. And since then, I've been working on lots of exciting and challenging projects, which I hope I'll have the chance to talk about later.
Yeah, for sure. And so what is your official role now? I don't think I actually called that out at the beginning.
My role is a senior speech scientist in the text-to-speech team at Amazon. And we work on text-to-speech voices for Amazon, including Alexa and AWS Poly voices.
Very cool. Very, very cool. That's incredible. A bunch of people in the chat are commenting on just what a remarkable career you've had and kind of the exposure you've had to all of these technologies. It's absolutely amazing.
It may sound random from other people's perspective, but I have a theme, which is an interest in language and speech.
Yeah, mine is not nearly that similar. I have a degree in psychology, actually. But while I was in college, I should have noticed that I was taking classes like calculus and computer science and those kinds of things as like a minor almost, but pursuing a psychology degree because I thought I wanted to be a doctor. My dad was a doctor, a dentist, and that was a path that I was on as well. And I was getting A's in all of my calculus, computer science, like hardcore math science stuff. Mm-hmm. In my psychology classes, I was getting B's and C's, and I should have put it then. But I just didn't. And so I finished my psychology degree. I got out of school and realized I knew enough about building websites and things to kind of get dangerous. And I went and started building some software And before I knew it, here I am at Amazon, and I'm writing code every day and building awesome stuff and experiences on a lot of the technology that you're working on for people to use on Alexa. So it's very, very cool.
It's interesting where life takes us.
So let's talk about that a little bit. So you mentioned that you have a master's and a PhD in phonetics. I imagine there's a pretty natural translation to that, but how does that help you in the domain of like speech synthesis, which is what you're kind of working on?
So phonetics is the study of sounds of languages, and text-to-speech in its essence is making computers speak. And in order to be able to model how humans speak, we need to have an understanding of how we speak. And phonetic knowledge is crucial, especially in the TTS front end, which is the bit that converts from text into phonemes, because we need to know how letters correspond to sounds, first of all. So we might have a lexicon or pronunciation dictionary that defines how each word should be pronounced, but the pronunciation might change depending on the surrounding context.
Yeah.
So, as a simple example, when you say 10 pin or 10 pins, the N at the end of 10 is more likely to be M rather than N. So it's 10 pin. And that kind of knowledge needs to be built into the TTS system. So that's where phonetics comes in useful. And previously, a lot of these things were coded as rules. And nowadays, more and more of these are being replaced by machine learning models. But even then, phonetic knowledge is useful in analyzing errors and discovering patterns. So, for example, you might find that sample synthesized from a model has issues in certain contexts before a pause. And knowing that this happens with certain classes of phonemes helps you dive deep into the training data in a systematic fashion. And also in TTS, we're constantly striving to make the synthesis as natural sounding as possible. And in order to achieve that, there have been many advancements in terms of technology using various machine learning approaches. But the motivation for many of these machine learning approaches often comes from knowledge and understanding about human speech perception and production, which is what phonetics is about.
Yeah.
And so these are some of the ways in which phonetics is important in the domain of TTS. And so I think it's important that researchers with a phonetic or linguistic background work together with researchers with machine learning expertise, and we learn from each other.
Yeah. Now you said your primary languages are English and Japanese, and you've mentioned French. I have two questions there that kind of dig into this a little bit. The first one is, how many languages have you been, I don't want to call fluent, but like I took French for 9 years. I would never have called myself fluent. But like, how many languages have you been capable of speaking in your life? It seems like it's a lot.
So currently, I would only say that I'm fluent in Japanese and English.
Okay.
I used to have sufficient fluency in French to be able to conduct business interviews. But as I said, my French has been going downhill since I was 18. And then there's a bunch of languages that I sort of took up at university. I have sufficient knowledge of the phonology of the language, but I wouldn't say I was fluent. Like ancient Greek, for example, even as I was learning it, people asked me how to say hello in ancient Greek. I had no idea, but I could say John was baptized, or
Sure.
it would be useless
Sure.
conversation.
Yeah. No, that makes sense. And are there specific languages that you find give you more insight or understanding of how, like, when you're piecing phonemes together? Are there ones that you tend to lean on more as like, well, this is a foundational way I think about this in like ancient Greek or English or Japanese? Are there languages that you tend to pull from more than others when you look at how to analyze these, or are they completely independent?
So there are groups of languages, families of languages, and like Slavic languages have certain similarities, Romance languages have certain similarities, and so on. But in general, the phonetics of languages is very different from language to language.
Sure.
And so in developing a TTS system, you often have to have expertise in each language.
Now, I've always heard that English is a nightmare for a lot of this stuff. Which language have you found, or at least in your experience, has been the hardest?
So in terms of learning to speak. So I'm currently learning Polish, and I'm finding it extremely difficult, but that's partly because I took it up late in my life. But in terms of like how letters correspond to pronunciation, Polish is a very straightforward language. So for a text-to-speech system, purely from that perspective, it's a straightforward system. The hardest language that I've worked on for text-to-speech is Japanese. And the Japanese writing system consists mainly of 3 scripts, one of which is called kanji, which is basically Chinese characters borrowed into the Japanese language. And kanji is highly homographic, which means that the same character can be pronounced in many different ways, and it changes the meaning of the word. So if you imagine the word in English, the word spelt B-O-W, it can be pronounced bow to mean bend forward, or it can also be pronounced bow to mean shooting the weapon they use for shooting arrows or ribbons. And the meaning, and hence the pronunciation, varies from context to context. And Japanese is full of characters and words like that. And the majority of kanji characters have more than one pronunciation. And in an extreme case, if you take the character meaning life or raw, there are more than 150 ways of reading that character, depending on the context it's used in. And so in order to predict the pronunciation of Japanese words, hard-coded rules are not going to cut it, and we need machine learning models. And humans learn these readings over a lifetime, so it's no wonder that it's a challenge for these models.
Right.
And another challenge is that Japanese doesn't have spaces between words. In TTS, one of the first steps in the TTS front end is to split the sentence into words. And in English, you can deterministically do that by looking for spaces. But Japanese strings words together without spaces in between. So you need models to predict where a word ends and the next word begins. And here again, we use machine learning models to predict the word boundaries. And earlier I mentioned that Japanese has 3 scripts, and one of them, kanji, has many readings, and disambiguating pronunciation is a challenge. So you might be wondering, what about the other 2?
Yeah.
And the other 2 are called hiragana and katakana, and they're what's called syllabaries. So the pronunciation is indicated in these characters, but there's a catch. An additional complexity is that Japanese is a pitch accent language, which means that if you say hashi or hashi, the 2 mean different things. One is chopsticks, and the other one is bridge.
Wow.
And the pitch accent is not indicated in writing in hiragana or katakana. So we do need kanji to indicate the meaning and implicitly indicate the pitch accent. And it doesn't end there, because do I still have time to go on a bit more?
Yeah.
So the pitch accent of a word can be looked up in a dictionary, a pronunciation dictionary, but the pitch accent can change when it's used in a phrase or a sentence. So here again, we're dependent on machine learning models.
Wow.
And so these present the biggest challenges for TTS when it comes to accommodating the Japanese language. And as I said, I worked on developing the TTS for many Indo-European languages in the past, but Japanese has been the most challenging one I've worked so far.
I would say so. And so, I mean, it should be noted, like, you led the development and the launch of the Japanese voice for Alexa, right?
Mm-hmm.
Man, that's an incredible number of challenges to think about. As I think about the words in English that I use, I can sway the meaning of my sentence with tone, not like you're describing. I might be able to add some sarcasm or like a slight variant on what I'm trying to say. But someone mentioned it in the comments. Could you imagine messing those 2 terms up and suggesting that we build a bridge out of chopsticks? That's a really massive difference in just a slight tonation.
Yeah, so that's a great challenge for Japanese. And even if you don't misunderstand the context, getting the pitch accent wrong can delay the customer's understanding of what the text-to-speech, or what Alexa said. And so leading to a misunderstanding is really bad, but even if it doesn't, if you don't get the pitch accent right, it leads to a very bad customer experience. And initially we didn't have a very good model for the pitch accents, and we had feedback saying that it sounded like a foreigner, because for foreigners, pitch accents is something very difficult.
It would be like me trying to record all of that. It would never work. I'm not a student of Japanese at all, but it does seem to me like it would be very, very easy to just have all the words come out properly, but have it sound like gibberish because it's not the right tonality. Is do you find that as native Japanese speakers, there's a lot of interpretation that happens as you speak, because you have to make sure that that you understand the right tonality? Like, you hear the word and maybe they didn't say it with the right tone, so they said the word, and it could either mean chopsticks or bridge, but clearly in the context it means bridge, so I know what they're talking about. Is there a lot of that happening as you listen to someone?
Oh yes, totally. As human speakers, we're doing that all the time, and I'm always amazed at how clever we are as human listeners and also speakers to be able to do all of this. And,
it is remarkable.
Teaching machines to do that is so difficult.
Yes. Well, I'm glad you're the one doing it and not me, because this sounds impossibly hard. So a couple of months ago, I got to speak with Andy Breen, who's our senior manager of TTS research. And we talked a lot about some of the more recent speech advancements, like Alexa's speaking style adaptation, making her sound more natural. That's a big thing for us. Can you tell me about what you're working on?
Yeah. So we've been working on a model that enables the same voice to speak multiple languages. We've launched Alexa in 15 locales, but each language has at least one Alexa voice. And that's because TTS voices are based on recorded speech from voice talents. And in order to ensure that Alexa sounds native-like in each language, we have a different voice talent for each locale who can speak that language fluently. And this means that the Alexa voice speaking Spanish, for example, sounds different from the Alexa voice speaking English. And with the new multilingual model that we've been working on, we can now have the same voice speaking Spanish and English. And this is actually what we launched a few weeks ago. Yeah.
Okay.
And, so back in 2019, we launched the multilingual mode for Alexa in US English and US Spanish, which lets customers address Alexa in either language and receive the response in the same language. But as I mentioned before, the English and Spanish responses were in different voices. And as a result, the multilingual mode felt like speaking to two different people.
Sure.
And with the new model, we took Alexa's multilingual capabilities a step further, and we introduced a multilingual mode that uses the same voice for English and Spanish, even though we only had English recordings from the voice talent. And this is a nice link to the work that I was doing for my PhD more than 10 years ago, even though the technology we're using now is very different and much more advanced.
Wow, that is very cool. So let's dive into that a little bit. We've got this capability where we're able to speak to the same voice in different languages, different accents. They should sound native in both places. How does that actually work?
So this has become possible because of neural text-to-speech, which might have come up in previous interviews that you've done with like Andy. So we use neural networks to generate speech directly from phonetic renderings of input text. And early versions of Alexa used concatenative methods, which means we string together tiny snippets of recorded speech. And with traditional TTS systems, one way to make a voice speak another language was to map the phonemes of the target language into equivalent phonemes in the speaker's native language. But this resulted in a heavy foreign accent. And another approach was to find bilingual voice talents and record them speaking both languages, which is not always feasible and limits the number of languages that we can combine. And so our new multilingual model based on neural TTS solves both problems. And in the past few years, the Amazon TTS team have used MTTS to transfer vocal inflections, or what we call prosody, to from a recorded voice to a synthesized voice, or to change the speaking style of a synthesized voice to make it sound more like a newscaster or a DJ. And in the same way, NTTS lets us transfer Spanish-speaking capability with native speaker accent and fluency to another voice, which has no Spanish recordings. And although we're using the technology initially in a bilingual mode, experiments we've done indicate that it should generalize to multiple languages.
Wow. So you could potentially have one voice that could speak 8 languages.
Literally, yes.
Oh my gosh. That's so cool. So let's get into that machine learning a little bit. How do you train a model like that? This seems like an impossibly hard challenge, but I'm very interested to hear how do you go through that process?
So we train a model on recordings from multiple speakers in multiple languages. And we start with our standard neural TTS platform, which is an encoder-decoder architecture with attention mechanism. And we take as input a sequence of phonemes. So the phoneme sequence is passed to an encoder, which outputs a vector representation that encodes acoustic information about the phonemes. And we want this encoder to project acoustically similar phonemes from different languages into the same region of the representation space, regardless of speaker identity or language. And in addition to the phoneme sequence, we use 2 additional inputs, a language ID code and a speaker embedding. So speaker embeddings are a vector representation that encodes the characteristics of a given speaker's speech.
Okay.
And the embeddings for similar speakers are meant to cluster together independent of the language that they speak. So the system can use these embeddings to extrapolate how speakers might sound like in different languages. And so then the phonetic encoding, together with the language ID and the speaker embeddings, are then passed through an attention mechanism. And the decoder then uses the speaker and language embeddings to produce the correct acoustic content for a particular speaker and language. And so that's the gist of how it works. But if you're interested in more details, we've published a blog post in Amazon Science. So
Awesome.
it has a diagram which might make it easier to understand.
Cool. And so for our audience, Aaron just posted this in the chat, but you guys can find the link there. But if you're looking for any articles on this kind of stuff, like the science behind how Alexa and a lot of the research that we're doing at Amazon, you can find that at amazon.science. It's a website. We have a blog. There's all sorts of great information there. And I know Kayoko has a blog post specifically on that Aaron just posted in the Twitch chat. I'll pop that here on the screen as well. It's amazon.science, and the article is called English Language Alexa Voice Learns to Speak Spanish. So you can try and type that link in from what I just put on the screen, or you can click on the link that's here on Twitch. I don't know if Aaron is also posting this to LinkedIn and Facebook and YouTube, the other places that we're broadcasting, but if she is, you'll be able to find those there. All right. So this is, I got to be honest, there's a lot going on there, right? As we talk about all of this processing and speaker embedding and language IDs, all of these pieces are pulled together. I think one of the most amazing pieces of this for me is that all of this is done in milliseconds, right? I mean, I think being able to accomplish these tasks, I've been in software a long time in my career. There are things that just take time. And this seems like one of those things that I have to reference a bunch of data. I have to look at models. I have to pull all this information together, and I have to do it like that. That's amazing to me. Is there anything special or unique about our approach to be able to do it so fast? Or is that just I don't know a lot about building the underpinnings of machine learning engines, but I'm curious, is there anything special about what we do that optimizes for speed?
So there are several machine learning approaches that you can use. And we not only look at the performance in terms of accuracy, or in the case of polyglot, not only accent and naturalness and similarity, but we also look at like the latency and memory consumption. So we do a thorough testing in those aspects too, in order to not in order to be able to provide the response immediately without the customer feeling any delay.
No, that's great. So speaking of customers, what does all this mean? So we do all of this work to think about like multi-language, multi-voice. What does that mean for customers? So what is it that really solves for them?
Mm-hmm. So in practical terms, so there are two multilingual modes for Spanish-speaking customers in the US. We have English/Espanol US and Espanol/English US. And customers can now select the language option English/Espanol US to get the same voice speaking English and Spanish. And if they prefer this separate voice experience like before, they can select the Espanol/English US option. And we hope that this will lead to improved customer experience because you can get the same Alexa voice regardless of whether you're speaking Spanish or English. And this technology opens up the possibility for us to have the same voice, same TTS voice, speaking many languages, like you said, whilst keeping the same voice. But of course, this may not make sense. And we're always driven by customers. So we'll keep an eye on what customers are saying and use the technology in a way that will be most useful for them.
Yeah. Now, I've heard we do something similar in India, right? We have Hindi and we have English. Is this following a similar process?
So the voice that we have in India uses the traditional approach. One of the traditional approaches that I mentioned earlier, where we record a bilingual voice talent.
Got it. Very good. All right. So I think it was Interspeech 2020. You had a publication that you authored with some of the members on your team. And it was about singing synthesis, which is another really interesting thing to talk about. So what other advancements do you see on the horizon for speech technology? Because I didn't imagine synthesizing a human singing voice was something we would do soon, but here we are. So talk to me about that.
So with neural TTS, it's now possible to have more consistent and smoother synthesis than before. But the neutral style, which is the standard speaking style for TTS systems, can be boring. And the real advantage of NTTS is its adaptability and versatility. So, for example, the TTS team at Amazon have published work on style synthesis and emotional synthesis using neural TTS. And these are ways in which we're working to make TTS more and more natural and as close as possible to a human. And the work on singing synthesis, which you mentioned, takes that approach further and explores human vocal capabilities beyond speech.
Wow.
And I think TTS will also in future be able to understand and be aware of the context and dynamically adapt to it. And this would enable TTS voices to speak in a way that is appropriate, not only for the context of that isolated sentence, but in the context of the previous dialogue or adapting to the customer's mood. And I also see the technology that the technology will probably grow in areas where they surpass human capability, like we have seen with the multilingual model. So this is a technology that allows the same voice to speak many more languages than an average person can.
Right.
And this has been made possible by the power of machine learning and its ability to learn from data and transfer the knowledge. So
when we talk about the average person, we're obviously not talking about you. We're talking about the average. You're far above the average when it comes to speaking languages, but this is so exciting.
Yeah, the thing, advancements in technology have made it possible to expand the TTS capabilities in many different ways. And for example, there might be a technology which may make it possible to produce non-speech sounds like laughter, interjections, and other paralinguistic sounds. And these are some of the ways in which the technology could evolve in the future. But at Amazon, we like to be driven by and guided by customers.
Yes.
So once we find some space where the new technology makes customers' lives better, I think there's lots of things that we can do with the technology. But we also need to be aware that customers' expectations will also be changing. And so the bar is constantly rising, but we'll always try to do what's right for the customers.
And I think that's the right approach. It's amazing to me how often, being an Amazon employee, that question comes up in a meeting.
Mm-hmm.
What do our customers want? Do we have data? Have we talked to them? Do we have feedback? And it's amazing that we do have feedback. Customers are really willing to let us know what's going on and what they think and how they feel about our software. But then how we can turn that into actually improving our products for them is amazing.
That's something I find really exciting about working at Amazon, getting customers' feedback and working on that feedback to provide something better.
I very much agree. All right. So I think as we wrap this up, I want to talk about science careers in general a little bit with you. if you were talking to a young professional or a student that's embarking on their career or thinking about this, I have this exact scenario happening in my home. I have my daughter turned 17 today. I cannot believe that I'm old enough. Thank you. I can't believe that I'm old enough to have a 17-year-old child, but I do. And she is very interested in finding a way to work at NASA. She likes engineering. She likes computer science. I think that she'll probably find her pathway there. But at 17, she's still got a long road ahead of her. So if you were giving some advice to someone like her, what would your advice be for thinking about getting into career options in science?
So at Amazon, we have something called the leadership principles, which we use in, as you know, every day, which we use every day in all kinds of situations, whether we're discussing ideas for a new project or deciding on the best approach to solve a problem. And I think many of these qualities are important as a scientist too. So I'll just mention a couple of them. The first one is dive deep. So as a scientist, diving deep into problems is probably something that comes naturally to you and something you enjoy doing anyway. But when you're swamped with work or when you're under pressure to meet a deadline, it's easy to overlook this. So this is something that I have to keep telling myself. And there's a quote by Einstein that goes, "The more I learn, the more I realize how much I don't know."
Yes.
And I like this process of learning more, realizing I don't know anything, becoming curious, asking questions, and learning more, which takes us to the next point, which is learn and be curious. So by a repeated process of diving deep, you become an expert in your field. And being an expert in your field is important, but I think it's also to have a broad perspective. So looking back at my career, I feel like I was always putting myself in a position where I knew I needed to learn more. And being in that position gives you the opportunity to learn more and expand your knowledge and skills. And as a scientist, this is something that you probably enjoy anyway. And previously in text-to-speech, we adopted a lot of the techniques employed in speech recognition. And nowadays, more and more machine learning techniques are applied across different domains, not just speech. And we're using approaches developed outside of the speech domains, which means that we see researchers from completely different backgrounds joining us in TTS. And it's great that we have scientists with varied backgrounds in our team now, because it helps us have a wider perspective and we can learn so much from each other.
Yeah.
And as a scientist, your skills are flexible and you can apply a similar technique for solving problems in many different areas. So don't be afraid of looking for opportunities outside of your specific area of expertise.
Yeah, and calling out to that specifically, I think that's something that people forget about in their careers, is that, like, there's a lot of people that identify with their job or their role, and they're like, I am this, right? And I think the people that are the most valuable, the people that have the most success in their careers, are the ones that recognize that we are all problem solvers in specific domains. And the more that you think about, how can I solve problems in my domain, whatever that may be, will allow me to have the freedom and flexibility to move and do the things that I want to do, because I'm a good problem solver. Yeah. And I think that's a skill that is not emphasized enough, at least in United States educational institutions like high schools. I don't think they focus enough on problem solving. They focus way too much on memorization and rote learning. It would be nice to see more problem solving driven development or of education, for sure.
I agree.
So is there anything outside of the learn to be curious, dive deep? Do you have any, like, there's always some non-technical aspects to like careers that really call out to people? Is there anything? I'll give you an example of one that I use all the time. And that is it's build a network, meet people, go out of your way. This is something that is always big advice for me, is that, you know, there are groups of people talking about everything. I would bet that there are scientists meeting virtually or in person that get together and they talk about hard problems and network with each other. And when you need a new job, you're like, you know what? I met that person at this cool thing. I'm going to reach out to them because they seem like they're doing some cool work. So building a broad network, don't just live in your little bubble, but broaden it as much as you can is my biggest piece of advice for people. What do you have?
I think mine is similar. So mine would be mine would be about communication. So regardless of whether it's a career in academia or in the industry, communication skills are crucial. For example, when explaining about your work to your managers who may not necessarily be from the same background. Or if you go to a conference, you might have to describe your work to someone from outside your field. And you need to be able to see things from other people's perspective and explain your work clearly. And also collaboration is crucial in research. And there again, communication skills are essential.
Yeah.
So I think always keep in mind the synergy that comes from communicating well with others.
Yeah, I think that comes together. The problem solving, if you think about the word empathy, it can carry a lot of meaning. It's not always just feeling the emotions that others are feeling, but it's being able to recognize from someone else's perspective how they think and act and behave.
Yeah.
And I think that that's also a big piece of what you're describing here, is the idea of being empathetic to others and being able to understand what their perspectives are. I have a new leader on our team, and she just made this interesting comment about how when someone offers you criticism, our natural instinct is to deny it. Like, that's not true. I'm not like that. That's not who I am. But she said it's really interesting to be able to flip that around and instead say, how is that true? How do people then perceive my behavior or my action or my writing or whatever it is in the way that they described it? And it's an interesting way to flip it around, because you really start to take into consideration what other people have on their minds and how they work.
I think that empathy also brings us back to the problem solving point that we talked about. We try to think about how to solve different problems, but using similar techniques that we've used in different area. So trying to sort of change your perspective. So I think there's something in common there.
Very, very much. All right. So I know there's a bunch of interesting launch blog posts that have been out there about TTS on the Amazon.science website. If any of you that are watching would like to learn more about those announcements, about what Kayoko or the Alexa Science team are working on, or if you have we have lots of scientific endeavors that are constantly being worked on and shared in white papers and other things, please visit Amazon.science. I can't recommend it enough. There's a lot of really great, interesting information there. Things like these interviews are also posted there, so you'll have an opportunity to find our past catalog of interviews like that. But Kayoko, I want to thank you so much for spending time with me today. This has been eye-opening for me, for sure, and I think for our audience, based on the comments that I've seen, this was a fantastic conversation. Thank you so much for sharing your thoughts.
Thank you so much for having me, and thanks everyone for joining.
Certainly. All right. Well, that's it for today for Alexa and Friends. I want to thank you guys all for tuning in. We will be here again next week and every week, hopefully going forward. Lots of interesting guests, lots of interesting things to talk about. So on behalf of Kayoko and I, thank you guys all so much for tuning in today, and we'll see you all again very soon. Bye-bye.